Okay, good day and welcome to our next recording for Math 10, the measurement unit. Today we'll be tackling the volume of a pyramid and a cone. The volume of right pyramids and right cones. All of these shapes here, you've got your cylinder, you've got your hexagonal prism, you've got your rectangular prism. If it was a square, it'd be a cube. You've got your triangular prism. All of those, you take the area of the base times the height. So for this one here, length times width times height. For the rectangular, that's the easiest one to do, of course. For the cylinder, it's a circle, so pi r squared times height. Pi times radius times height. The triangular prism over here is, of course, you take the bottom base and its height, base times height divided by 2, and then times the entire length to get that volume. So basically, essentially, the area of the base times the height gives you the volume of any of these shapes. And the volume is simply, of course, how much can you put on the inside? What does it take to fill a bucket? Well, a bucket is in the shape of a circle, so you'd find the area of the circle times the height of your bucket, and there you have it in cubic centimeters or cubic feet or whatever unit you're using. Maybe it's massive and you're using cubic meters, but it's the area of the base times your height. Now, if we go over here, look at this shape here, a hexagonal prism. Again, area of the base times the height. Now, if we're doing the volume of a pyramid or a cone, which we'll be doing in today's lesson, we do the same thing. Area of the base times the height, but we divide by 3. It's a third, because it comes up to a peak here. So you don't have, this is essentially like any of those other shapes, except the sides come together and make a peak. And so then you have, of course, less volume. Now, why do we divide by 3? Because volume is in cubic feet. When we were doing surface area of pyramids and cones, we would do divide by 2 because surface area is in square feet. Now we're doing volume, which is in cubic, or whatever volume, cubic centimeters, cubic feet, cubic meters, cubic inches, depends what we're doing. Divide by 3 because volume is cubed. Again, for the surface area, we were dividing by 2 because its surface area is square. Okay, so let's look at some examples. Calculate the volume of the right square pyramid to the nearest cubic inch. So this is a square pyramid. We have the measurements of the square. It's a 4x4 square. Now we have a slant height of 6. Now for volume, we want to have the straight height, not the slant height, the straight height. Okay, so the first thing we'll have to do here, surface area is on the outside, so you wanted the slant height. Volume, you want the height straight up the middle in there, because volume is what you have on the inside. Surface area is on the outside. So this square is going to be easy, a 4x4, but we need the height. So we have a slant height of 6. You can easily do this. So the distance from the outside to the middle, if this whole thing is 4, distance from the outside to the middle is 2. So let's use the 2 and the 6 in a squared plus b squared equals c squared to get this height going up, right, from the middle here. So here we're going to have a 2 from the outside to the middle is a 2. This is a 6. That will easily give us the straight height. So, page 38, example 1, a squared plus b squared equals c squared, to get that straight height. So this is obviously the 4, the 2 is the short side. So 2 squared, the one we don't know is the middle side, b squared, And 6, that outside slant, is obviously the longest side, squared. 2 squared is 4, plus b squared. 6 squared is 36. 36, take away 4. Because when we know what the long side is, we have to subtract. 32, square root of 32 comes simply 5.65, so we'll call that rounded up to 5.7. So we have a straight height inside this pyramid of 5.7 inches. So from here, from the middle up to the top, we have 5.7 inches. We now have all the information we need to find the volume of this square pyramid. And once we have all our necessary numbers, volume is one of the easiest calculations to do. That square is 4 by 4, 4 times 4, and our height is 5.7 that we just found. 4 times 4 times 5.7. 91.2. Divide by, remember this is volume and it's a pyramid, 3. 91.2 divided by 3. 30.4 inches cubed. You could put 30.4 cubic inches of whatever in the pyramid. Sand, air, water, whatever. Okay. The other example on page 38 is essentially the same. Let's look at the one on page 39 over there. Right here, page 39. We have a pyramid with, this time we have the straight height, and it's a rectangle. It's 5.4 by 3.2 with a straight height of 8.1. So again, this becomes relatively easy to do. Page 39, and this will be example 2. And we can do, there's 2 examples here that are similar with a nice straight height. So let's do them both. Let's do both of these. So we have the base, so this is example 1, 5.4 times 3.2 times 8.1. $139.96, so we can round it up to 140. And then 140 simply divide by 3. 46.6, 46.7 centimeters cubed. Let's look at on the other one on page 39. Don't have a bit of a glitch, recording glitch. Don't have a picture of this one, but it has the bottom rectangle 3.6 by 4.7 and a height of 6.9. So this is part 2. 3.6 times 4.7 times 6.9. $116.7. $38.9. Cubic centimeters. Meters, actually. The problem was giving meters, so we'll go with meters. We'll go with that. So that's a pyramid. Area of the base, length times width of the bottom, whether you're doing square or triangle, doesn't matter. Whatever you do to find the area of the shape. A square or a rectangle is length times width. A triangle is base times height divided by 2. Just find the area of the bottom, multiply the height. If you don't have the straight height, you have to find it. If they're giving you the slant height, you got to find the straight height. And that is, of course, Pythagoras. Now, let's look at some cones. Here's a cylinder. A cylinder is simply a circle, pi r squared, pi times radius times height. You can get 3 cones into one cylinder. The volume, if a cylinder has the same circumference of circle and the same height as a cylinder, then you can fill up that cone 3 times with sand or whatever, and it will fill the cylinder. So a cone is a third of a cylinder, thus divide by 3, and we're also dividing by 3 because we're dealing with cubic feet. Another reason for dividing by 3. So let's have a look. We have a couple of examples that we can work through. Page 40. We have a pyramid, no, a cone, sorry. With the radius of 12. And a nice straight height of 18. Excuse my fancy drawing. So we want the area of the base times the height divided by 3. So to find the area of this circle, we're given a diameter, we need a radius. 12 divided by 2 equals 6. Now we can go ahead with pi, with area equals pi r squared. A equals pi times 6 times 6. Pi times 6 times 6, because that's squared. 113.1. 113.1 times your height, 18. 2035.8. Divide by 3. And the volume is going to equal whatever that is. 678.6. 0.6 inches, cubic inches. Okay. They have another example that's identical to this one on the page. Let's do one where they are giving us the radius, and they're not doing one like that here, so we're going to make it up. We're going to use this example. We're going to use this one. This is 4, and this is 13. So, radius of the circle, 4, height, pyramid going up, 13. So, again, area equals pi r squared. Pi times radius squared. Pi times radius times radius. A equals pi times 4 times 4. 16 times pi, if you like. 50.26, which is 50.3. And now we're going to go with our height. 50.3 times 13. 653.5. Divide by 3. 217.8. And we're going to say that this was centimeters cubed because we kind of made this one up. Centimeters cubed. All right, that should be enough examples. So we're going to be dealing with cylinders and rectangular prisms. All right, let's have a look. Take all the exercises from page 42. So homework, page 42. Your question numbers, let's do 4. Let's do 6. Let's do 8. Let's do 9. That should keep you busy for a while. 4, 6, 8, 9. Let's have a look on page 42. Start out with a couple of rectangular prisms, right? Length, those are easy. Length times width times height. Length times width times height. Right. A couple of cylinders. Pi r squared. Pi times 5 times 5 times 20. Right. 16 is the diameter of the circle. Half of that would be a radius. Pi times 8 times 8 times 4, right? Area of the circle times the height is your cylinder. Pyramids. For each one, they're giving us this straight height. So there's no need for Pythagoras. They're giving us straight. These are square pyramids. 3 times 3, right? Times 6. You're going to divide by 3, right? Because it's a pyramid now. Here's a rectangle. 6 by 7, still giving us the straight height, times 12. Divide by 3. No Pythagoras needed here. Giving us the straight heights. You should be able to do all this with relative ease. Area of the circle here, pi r squared. There's the radius, 2. Right? Pi r squared. Pi times radius times radius. Times 9 times the height. Divide by 3. Here we have a height of 11. The diameter of 32. So you want the radius. So get half of 32. Gives you 16. And work from there. Alright. 4, 6, 8, 9. Giving you all the questions that have diagrams. And that's about it for this concept. Yep, I think that'll do. And I think 2 lessons will be enough for the week. So this is going to be the last math post for this week.